To illustrate how supply chain contracts can be used to determine order quantity and evaluate the supply chain efficiency, let's look at the basic supply chain. Susan is a manager at TechWorks and supplies computers to big box retail store. Susan offers to sell computers to John, the manager of big box, under a wholesale price contract. Under this contract, TechWorks has a per unit production cost of $100 and offers to sell to big box at the wholesale price of $300. Big box then sells to consumers at the retail price of $400. Consider a single sales season in which the consumer demand is normally distributed with a mean of 1,000 and standard deviation of 200. We assume that any unsold units at the end of the sales season have zero salvage value, and any unmet demand will be lost. Big box must figure out how many computers to order before the sales season to maximize expected profit. To answer this question, John must identify costs so he can balance the trade-off between ordering too much or too little. The cost of overordering is just the cost of a unit, so the cost of overordering in this case is equal to $300. The cost of underordering is the potential revenue not realized from a sale, or the retail price $400 minus wholesale price $300, which is equal to $100. Knowing our costs, we can calculate the ratio of underordering to total cost. We call the ratio the critical fractal. In this case, the critical fractal is equal to $100 divided by $400, which is equal to 0.25. We can then determine the optimal order quantity that maximizes the retailer's expected profit. We do this simply by using the news vendor formula, which is implemented with the Excel built-in function, so-called norminf. Norminf takes the three parameters: critical fractal, mean of demand, and standard deviation of demand. So to answer the question, how much should I order, John calculates norminf with the three parameters given as follows: 0.25 being the critical fractal, 1,000 being the mean of the demand, 200 being the standard deviation of the demand. For comparison, we can calculate the optimal order for the entire supply chain. We call this the first best solution. In this situation, the cost of overproduction is the unit production cost, $100. And the cost of underproduction is the wholesale price minus production cost, which is equal to 400 minus 100. That is $300. It follows then that the critical fractal is equal to 300 divided by 400, which is equal to 0.75. We again use the news vendor formula to identify the optimal production quantity, this time with the critical fractal being equal to 0.75. This tells us that ideally the supply chain can produce 1,135 units. If we compare the first best solution to the wholesale price contract, we see that the optimal order quantity for big box is lower than the supply chain's optimal order quantity. The difference in quantity is due to the fact that the retailer has a lower margin than the entire supply chain. This is referred to as the double marginalization problem. Because TechWorks is only a supplier and does not sell direct, the first best solution cannot be used. So if TechWorks wants to increase revenues, Susan must figure out how to encourage John to order more computers for sale at big box. To do this, TechWorks offers big box a returns contract. Under the returns contract, the supplier again charges a fixed wholesale price for every unit. But for each unit of leftover inventory, the supplier pays the retailer a fixed refund. As a result, the retailer will order more knowing that they can get a refund on unsold inventory. Let's revisit Big Box and TechWorks, but this time using the returns contract model. Again, John must identify how much he should order. Production cost is still $100, the retail price is again $400, and the wholesale price remains to be $300. but TechWorks now offers to refund Big Box $266.67 for every unsold unit returned. Under these assumptions, John identifies the optimal order quantity for Big Box with the following calculations. The cost of overordering is wholesale price minus returns price, or $300 minus $266.67, which is equal to $33.33. The cost of underordering is the retail price minus wholesale price, that is equal to $400 minus $300, which is equal to $100. The critical fractile is cost of underordering divided by the total cost, which comes out to be 0.75. So using the news vendor formula, the retailer's optimal order quantity is equal to 1,135 units. If Susan and John agree on the returns contract for TechWorks and Big Box, we see that the supply chain is coordinated. The retailer's optimal order quantity is equal to the optimal order quantity of the supply chain as a whole. But both parties still want to evaluate if they are individually better off under this contract. To do this, they will calculate the profit realized under the different contract scenarios. This can be done by using simulation. Looking at the results, we see that because the returns contract allows demand risks to be shared among supply chain members, the returns contract achieves not only supply chain coordination, but also win-win outcome for both the supplier and the retailer.